This is Ramakrishna, Maths faculty. In this video class, we are going to discuss even functions, odd functions and identical functions. Let us start. Now, what is even function? Y is equal to f of x. If any function is given, replace x by minus x, f of minus x, and simplify that one. If you get the same function f of x, here f of x is said to be even function. And f of minus x equals to minus f of x, then f of x is said to be odd function. This is even function. F of minus x equals, if you get the same function, that is the f of x is said to be even function. F of minus x equals to minus f of x, then f of x is said to be odd function. Now we can discuss some different model questions here. First one, f of x equals to sine of x square plus 1 is there. Now f of minus x is equal to sine of minus x whole square, that one becomes x square only, plus 1, that is equal to f of x. Here f of minus x equals to f of x we got, therefore f is said to be even function. Second one, f of x equals to a power x minus 1 by a power x plus 1. Now f of minus x is equal to replace x by minus x, minus 1 by a power minus x plus 1, that is equal to, now we can simplify that one, whether we are getting the same function or not. A power minus x we can write 1 by a power x minus 1 by a power x plus 1. Now here you can take LCM 1 minus a power x upon 1 plus a power x. From these two terms I am taking minus common, minus of a power x minus 1 by here a power x plus 1. That is equal to minus of a power x minus 1 by a power x plus 1, that is f of x only. Minus of f of x. So here f of minus x equals to minus f of x. So here f of x is said to be odd function. Next question. Here this is the function given. Now we have to check the function whether it is even or odd or neither also. Now we can redefine that function. F of x is equal to here nothing means base e only, log x power m we can write, here modulus is there, modulus x into log e to the same base, that is 1 only. X is less than or equals to minus 1, here step of 2 plus x plus step of 2 minus x, here minus 1 is less than, x is less than 1. Here one more formula is there, x power log m to the base x, if these two are same, that is equal to m only, that is the logarithmic properties are there. So here these two are same, that is equal to x, here x is more than or equal to 1. Now again that is equal to modulus of x properties are there. Modulus of x equals to, we can write as is x, if x is the positive quantity, x is more than or equal to 0, otherwise a non-zero, non-negative value, x is a non-negative real value, we can write the same thing only. Minus x if x is less than 0, if x is less than 0. So here x less than or equals to minus 1 means x taking negative values only. If x takes negative values, modulus of x equals to minus x. X equals to minus x. X is the negative, so modulus of x equals to minus x. X is less than or equals to minus 1. Now here the same thing you can write here, step of 2 plus x plus step of 2 minus x. Here minus 1 is less than, x is less than 1. X is more than or equals to 1. Now this is the function f of x. Now replace x by minus x. F of minus x is equals to, replace x by minus x. Minus into minus, that one becomes plus. And minus x is less than or equals to minus 1. Here step of replace x by minus x plus step of minus into minus plus x, here we can get minus 1 is less than, minus x is less than 1, minus x is more than or equals to 1. Now f of minus x is equal to here x by multiplying or dividing with a negative quantity, inequality sign changes also. Here we are multiplying with minus into minus plus x less than or equals to becomes greater than or equals to minus 1 becomes plus 1. Now here step of 2 minus x plus step of 2 plus x. Here also multiplying with minus. If I multiply with minus here, plus 1 more than x is more than minus 1. Write in the reverse order. Minus 1 is less than x is less than 1. Now here minus x. If I multiply with minus here, x greater than or equals to becomes less than or equals to plus 1 becomes minus 1. Now this is the function f of x. This is f of minus x. Now here you can check both are same or not. X more than or equals to 1. X more than or equals to 1. Minus x less than or equals to minus 1. Step of 2 minus x plus step of 2 plus x. The same thing is there. X lies in between minus 1 to 1. We got the same function. That is equal to f of x. So the given function f of x is even function. Next, fourth one. F of x equals to x plus x square is given. F of minus x is equal to replace x by minus x whole square, that is equal to minus x plus x square. So this one we can't write minus half f of x or f of x. So this is neither 1 1 nor odd. Neither 1 1 nor odd function, that one. Next, fifth one. F of x equals to secant x plus x square minus 9 whole by x into sin x is given. Now you can find f of minus x. Secant of minus x plus minus of x whole square minus 9 by minus 9 sin of minus x. Here replace x by minus x. That is equal to secant of minus theta, that is secant theta only. Secant x minus x whole square, that one becomes x square minus 9 by minus x into sin of minus theta minus sin theta. Already minus is there. Minus into minus plus. We are getting the same function f of minus x equals to f of x. So even function. Yes, next one. This is the given function f of x equals to x into sin x plus tan x upon step of x plus pi by pi minus 1 by 2. Now we have to check is it even or odd or neither. Now first I am simplifying this one, x into sin x plus tan x whole by, here I can write separately x by pi plus pi by pi, that is 1 minus 1 by 2. Step of x plus integer, if any integer is given, we can write step x plus integer only. That is equal to x into sin x plus tan x whole by, this one I can write, this one we don't know, is it a real, that is a real value only. So here we can write step of x by pi, this is the integer, so we can write separately plus 1 minus 1 by 2. That is equal to x into sin x plus tan x upon step of x by pi plus 1 by 2. This is the simplest form of the given function. Now here you can replace x by minus x. F of minus x equals to minus x into sin of minus x minus sin x, and tan of minus x also minus tan x whole by step of minus x by pi plus 1 by 2. And in the step function properties are there, step of minus x, that is equal to minus step x minus 1. step of minus x equals to minus a step x minus 1. Now here f of minus x is equals to, that is equals to, from these two terms you can take minus common, minus into minus plus, x into sin x plus tan x whole by, here step of minus x we can write minus a step x minus 1, here plus 1 by 2 is there, plus 1 by 2, that is equals to x into sin x plus tan x whole by minus of step of x by pi minus 1 plus 1 by 2, that is minus 1 by 2, x into sin x plus tan x. Here from these two terms I am taking minus as common, minus of step of x by pi plus 1 by 2, that is equals to minus of, what about this one, that is the same as f of x1, minus of f of x. Therefore here f of minus x, I got f of minus f of x. So the given function is odd function. Sometimes we have to simplify that one. After that we can replace x by minus x. Here f of x equals to x power 4 plus x square plus 1 by x square plus x plus 1. Here numerator x power 4 plus x square plus 1, we can factorize that one. Here plus 2x square minus x square we can write. This is the completing square of x square plus 1 whole square minus x square, a square minus b square, a plus b into a minus b. In this place, if I substitute that one, these two terms gets cancelled, we can get f of x equals to x square plus 1 minus x. We can get x square plus 1 minus x. This is the function only. Now replace x by minus x. F of minus x, that is equals to minus x whole square, we can get x square plus 1 plus x. Here we got x square plus 1 plus x. Now here we can rationalize that one. Here x square plus 1 plus x into, rationalizing with x square plus 1 minus x whole by x square plus 1 minus x. Here I am rationalizing with the x square plus 1 minus x. Now here you can see by multiplying these two we can get the same thing only. That is equals to x power 4 plus x square plus 1. Here by multiplying these two we are getting x power 4 plus x square plus 1 upon x square plus 1 minus x is there. We are not getting either f of x or minus f of x. So here we say the given function is neither 1 1 nor on 2. Here f of x equals to step x plus 1 by 2. F of minus x is equals to step of minus x plus 1 by 2. Step x, already I told you, property, step of minus x equals to minus a step x minus 1 plus 1 by 2. That is equals to minus a step x minus 1 plus 1 by 2, that is minus 1 by 2. From these two terms we can take minus as common, step x plus 1 by 2, that is equals to, this is equals to f of x. So here f of minus x equals to minus f of x. So the given function f of x is odd function. Now we can discuss about identical functions. Two functions f and g are said to be identical if they defined on the same domain. Here, if any two functions are given, first we have to check the domain. If both the functions are defined on the same domain, and one more condition they have to satisfy. For all x belongs to domain, f of x equals to g of x. For all x belongs to domain, here both the range should be same only. The range of f of x should be equal to the range of g of x. Now, here some questions are given. Now, are they identical or not? Here what are the conditions? They should depend on the same domain, and for every x belongs to domain, Both the functions should contain the same range. Now by observing this one, root of x square, this function exists for every real value. This function exists for every real value. Instead of x you can put any real value. That one becomes a positive only. So square root exists for every real value. Now square root of x is given. Here instead of x if I take negative real values, square root doesn't exist. In the previous video class also we discussed that one. Square root doesn't, even the root doesn't exist for negative real values. So here what is the domain of this function? X belongs to 0 to infinite. 0 is included. Here we can't take negative values. Why? Because the square root doesn't exist only. So the domain of the first function is x belongs to real values. The domain of the second function 0 to infinite. So both are not defined on the same domain. So both are not identical. Both the functions are not identical. Now by observing the second function, second problem, here what is the domain of this function? Domain of f is equals to tan x doesn't exist for odd multiples of pi by 2 or minus set of 2n plus 1 into pi by 2 where n belongs to z. Tan x doesn't exist for odd multiples of pi by 2. And here domain of g is equals to, here 1 by cot x is given. Cot x doesn't exist for n pi. Tan 0 0, cot 0 undefined. Cot doesn't exist for set of all the real values minus n pi, n belongs to z. And one more thing, denominator should not be equals to 0. For odd multiples of pi by 2, cot value becomes 0 only. Denominator should not be equals to 0. 2n plus 1 into pi by 2. n belongs to z. Now here domain of the first function r minus 2n plus 1 into pi by 2, and what is the domain of the second function g? R minus n pi comma 2n plus 1 into pi by 2, n belongs to z. And by observing these two domains, they are not dependent on the same domain. So these two are also not identical. Here cot doesn't exist for n pi, and the denominator should not be equal to 0 also. 2n plus 1 into pi by 2. I subtracted both from the set of real values. And here third one, f of x equals to, here 1 plus cos theta formula is there, 2 cos square theta by 2. 2 gets cancelled. Here we can get square root of x square, always we can write square root of x square, always we can write modulus of x. Here two modulus of x properties are there. We can write x if x is the positive quantity and minus x if x is the negative quantity. Now modulus of x, here we are getting cos square x. The square root of cos square x, that is modulus of cos x. This is f of x. And g of x equals to cos x. Here this one exists for every real value. Domain of f, that is the real value. Domain of g also real value. This one also exists for every real value. This one also exists for every real value. But one more condition is there. Here both the functions are dependent on the same domain. But here we can't say both are identical or not. And if both the functions satisfy the second condition, then only we can decide. For every x belongs to domain, for every x belongs to R, here what is the range of f? Range of f we are getting only positive values. 0 to 1. But here range of f, that is equals to minus 1 to 1 we are getting. So for every x belongs to domain, f of x is not equals to g of x. So both the functions are not identical. Next, some more questions we can discuss. Here f of x equals to x is given. So this function exists for every real value, x belongs to R. And here g of x e power log x to the base e. By the definition of log exists for only positive real values. Here x should be more than 0. Here what is the domain of O? Domain of G, that is equal to 0 to infinite. Here what is the domain of O? F. Domain of F is equal to set of all the real values. So both the functions are not dependent on the same domain. So here we say both are not identical. And the next fifth one, by observing both the functions, we may get confusion also. Suddenly we can say both are identical also. But by observing the domains of both the functions, then only we can decide, and the range also. Now what is the domain of this function? This one exists for only x more than 1, x minus 1 more than 0. Here x minus 1 should be more than 0, x is more than 1, and here x is more than 2. What are the common values satisfying both the terms? X is more than 2. So domain of f, that is equal to more than 2, 2 to infinite. Domain of f is equal to 2 to infinite, both the sides open interval. Now here x minus 1 by x minus 2 should be more than 0. Log exists for only positive real values. X minus 1 by x minus 2 should be more than 0. Therefore here x belongs to, by taking the number line, we can say x minus infinite to 1 union 2 to infinite. For all those values, the function exists only. The logarithmic function will get log of a positive value only. Now here you can see the domain of f is equal to 2 to infinite. The domain of g is minus infinite to 1 union 2 to infinite. So both are not defined on the same domain. So both are not identical. Now by observing the sixth one, secant square x minus tan square x identity is there. We can say directly 1. Cosecant square x minus cot square x also 1. But here small trick is there. What is that one? What is the domain of f? R minus tan or secant doesn't exist for all the odd multiples of 90. 2n plus 1 into pi by 2. N belongs to z. This is the domain of the first function. And what is the domain of g? Either cosecant or cot doesn't exist for all the multiples of integral multiples of pi. N pi, n belongs to z. Now here you can observe both the domains. R minus 2n plus 1 into pi by 2, R minus an integral multiples of pi. So here both the functions are not dependent on the same domain. So both are not identical. And here also domain, this one exists for every real value. Domain of f is equal to, that is real values. Here also sin square x plus cos square x, both the functions are dependent. Domain of g, for every real value, both the terms exist only. So here both are dependent on the same domain. Domain of f is equal to r, and the domain of g also r. Both the functions are dependent on the same domain. But here we can see x square plus 1 is there. X square always more than or equal to 0. By adding 1, this is always more than 0. Signum function properties are there. Signum function properties are there. Signum of x, that is equal to, we can write 1 if x is more than 0. 0 if x is equal to 0. Minus 1 if x is less than 0. Now here you can see for every x belongs to r, what about x square plus 1? More than 0. If it is a f of x is more than 0, signum of f of x, that is equal to 1. If this value is more than 0, we can write directly 1. And if it is equal to 0, we can put the 0. If it is a negative quantity, we can put minus 1. Now here identity is there. Sin square x plus cos square x, for every x belongs to r, that is equal to 1. Here both are dependent on the same domain. And output also, for every x belongs to r, f of x equals to 1 we are getting. Here also for every x belongs to r, g of x equals to 1 we are getting. So here we can say both the functions are identical. Next one more. F of x equals to signum of x, g of x equals to signum of signum of x. Here what is the domain? Here this one exists for every real value. Here also this one exists for every real value. What is the here real value means positive are there, negative are there, 0 also there. So what will you get here? By taking the positive values we can get 1, by taking 0, 0, by taking the negative values minus 1. This is the range we are getting. Domain R, range minus 1, 0, 1. Here also domain R, what about the range? If I take the first two real values, signum of x equals to 1, and this is more than 0, signum of 1 that is equals to 1 only. And if I put 0, x equals 0, signum of 0, 0, signum of 0, 0 only. If I take negative values, signum of x equals to minus 1, by taking the negative values, signum of x equals to minus 1, signum of minus 1, this is the negative, so minus 1. Here both the functions are depend on the same domain and the range for every x belongs to R. Here f of x equals to minus 1, 0, 1, g of x also minus 1, 0, 1. So both are identical functions here. Now here, 10th one, here what is the domain of f? This one for every real value doesn't exist for 0. 0 by 0, indeterminate form we are getting. That's why, what is the domain of f of x? R my set of all the real values except 0. And what is the domain of g? That is that one exists for every real value. So both the functions are not depend on the same domain. So both are not identical functions. Now 11th one, log of secant inverse x is there. So secant inverse x should be more than 0. Here secant inverse x, it can take any value, either negative or positive, but here only positive should be there. So both are not depend on the same domain. So both are not identical here. Okay, thank you. In the next class, I am going to discuss about the composite functions.